So quickly, what is federated learning? The best way to understand it is to understand how centralized learning is done first. And I took this figure from an Intel project called OpenFL. And how centralized learning works today is that you have multiple entities. The key way to understand federated learning is to understand how centralized learning works and then how federated learning takes advantage of the decentralized aspects of data today. So in centralized learning, we have multiple entities. We have hospital A, hospital B, and hospital C. And to run some machine learning algorithm on this data and in a collaborative way, all the entities have to centralize the data to a centralized infrastructure. So what the key point to take here is that the data has to physically move to a centralized location. And once this data is in a centralized location, such as in the training infrastructure that is built, then we can create a machine learning model that each entity can use. Federated learning provides a way for each hospital to independently create a submodel of the model that we are aiming to create. So hospital A creates a machine learning model, hospital B creates a machine learning model, and hospital C creates a machine learning model. Each of these models is being created using each hospital's independent data. Now, once these models are created, only the model moves to an aggregation server that is shared amongst all the entities. And once this centralized aggregation server receives all the models, the aggregation server fuses these models into one model and then provides the model back to each entity. So what I'm showing here is that only the models move, the data remains physically in place at each entity. And again, just to show, it's synergetic with how EdgeLake operates. Data remains in place and only the queries move to the edge nodes where the data is. Here, in EdgeLake, only the models move across the network, not the physical data. So a key overview of federated learning is that everything is decentralized. So model training happens on local devices instead of a central server. And then one of the key overviews that this enables is that it allows you to ensure data privacy and security. And this is offered because raw data remains in place. Only model updates are shared between all the participating nodes. This also allows you to be efficient and scalable. And so there's no data transfer. Only the model parameters are moving. Physical data, which is the big chunk of the data, stays in place. And it also allows you to scale horizontally. So if you want to have more nodes participating in the training process, you can just deploy more nodes and that data on those nodes can be used to facilitate model training. Another key point with federated learning is that it allows for continuous learning. So rather than having to restart model training every time you get new data, you can use the previously aggregated models to adapt and retrain based on local user behavior in real time. And so one of the key use cases where federated learning is really beneficial that I want to highlight is a machine builder who wants to collaborate with machine operators who are its customers to utilize all the data to create a predictive maintenance machine learning model. So again, it allows multiple entities to collaboratively reap the benefits of a lot of data and machine learning all at the same time. And this also allows no one to have to share their private data with each other. So say I have my EdgeLake node. I'm going to just publish a training application on the blockchain. The blockchain is a shared metadata layer that each EdgeLake node has access to. And for people who don't know about the shared metadata layer, what it is essentially a shared drive. And you can think about each node has access to the shared drive and all the contents within this shared drive. So my EdgeLake node is going to publish a training application. And then each EdgeLake operator node that has the relevant information to facilitate the training that I'm intending to run has a local database management system with this respective data. And then it'll pull this training application onto the local node. And then once this happens, all the nodes that have this relevant information that will be partaking in this federated learning process will also pull the training application. Then my node will initiate a start training message onto the shared metadata layer. And this will result in every single EdgeLake operator node with the relevant information and that has the training application to start model training. And this model training happens on the data to their local database management system. And so the first node will publish a submodel called model A, and then the second node will publish model B, and the third model will publish model C. Now, these models will then be pulled by the aggregator node. For example, in this diagram, it's my EdgeLake node that is running the model training. And with an aggregation app on this node, I will create a unified final model that I will republish back to the shared metadata layer. Now, this final model can then be a source for an inference application that's sitting on each EdgeLake operator. And these nodes will then pull the final model into the inference application sitting on these devices. And now when data comes into these nodes, we can run inference and create outputs. And these outputs could be control decisions. Should I increase the temperature of the air conditioner, or sorry, decrease the temperature of the air conditioner, or manipulate my oil rig or whatnot. But essentially, the inference happens on the edge node directly. And the claim here that I'm making is that all you need to do is publish the training application on the shared metadata layer in EdgeLake, and EdgeLake will automate the entire federated learning process dynamically.